So we have here the notation for function, that is y equals to f of x, right?
Yes.
Okay. And here we are calling x as independent variable, since we are putting the value of x and then we get y. So y is dependent on x and we are calling y as dependent variable. Okay. And then we are talking about just graph of function. So here we see a function. If we consider a function just like y equals to f of x equals to 2x plus 1, and then if we put x equals to 1, then we get y equals to 3. We get y equals to 3. And if we put x equals to 2, then y equals to, we get y equals to 5. And then for x equals to 3, we have y equals to 7. So if we write the values in a ordered pair form, that is called ordered pair. Okay. So here the form is x comma y. That means we have to write first x, then value of y. Okay, then we have got from here, that is 1 3. That means for x equals to 1 we have y equals to 3, and then for 2 we have here 5, and then for 3 we have here 7. Okay. And uh, now if we want to plot the function which we have, that is y equals to f of x equals to 2x plus 1. That means y equals to 2x plus 1. Okay. Now we are going to plot this function. So at first we have to find some values for x, then for x and y's. Okay. We are going to just plot the graph of this function. Then how can we plot it? Here
Y.
uh,
Oh,
he,
okay. I'm sorry.
the system is called Cartesian coordinate system. In coordinate system basically, okay, if we see the graph here, we see here a picture of a graph, and there are two lines, both of them perpendicular to each other, right? Here is one,
Yes.
here is another one. Do you know this?
Yes. It's, I'm sorry.
Do
You
you
know
do you
what?
do you know this graph paper?
It's vertical.
uh, this one is vertical, and the name of this,
It's not.
that,
It's X and Y.
right, x and y. So vertical one is y axis and horizontal one is x axis. Okay. And the point at which they intersect, the point is called origin point, that is o, origin point. Okay. And the coordinate of this point is 0 0, that is 0 0, that is the origin point.
Okay. Origin.
At origin point, the coordinates of x and y Both of them are 0. So from the origin point, if we move along with x-axis to the right, then the values are positive.
Yes.
And from the origin point, if we move to the left along with x-axis, then the values of x's are negative. And here, uh, if we move along with y-axis, that is vertically, in the upward, that is called positive direction, and the values of y are positive, that is y are positive. And if we move downwards along with y-axis, then the values of y's are negative. Okay, so how can we plot these points in the graph paper now?
For the first one, x equals to 1
X
and y is 3. So
so
the intersection 1
so
and 3.
so it that is the point, right?
Mhm.
Okay, and for next one,
So x equal to 2 and y is 5.
y is 5,
2
so
and 5.
we have to move along with x-axis at first, in for positive direction, then we have to move
Right.
along uh, positive y, so it will be 5 here. Okay, and then next one is 3 7,
For
right? That is this.
the, yeah.
Okay, now if we add these points, just like this, then we will have a line just like this. Basically that is the graph of f of x equals to 2x plus 1. Okay, is it clear to you?
Yes. Yes. Here.
Okay, so basically what are the process to draw a graph of a function?
The process is to find if we know f the x, we can find the y.
Okay, then we have to put the values of x and y's in the graph and then join the points. Okay, but nowadays it is very easy for us to draw the graph of any function. You can go to Desmos or GeoGebra and just put the function over there, then they will show you the graph.
Okay.
Do you have the access to use Desmos or GeoGebra?
Um, the I have access of the one that you sent it to me. So yeah.
Okay, we can go for uh, Desmos. Do you see the graph here? Can you see the screen now? Okay, here just put the value of the function, that is y equals to 2x plus 1. That is the graph.
Oh, is it? Is this calculator?
Yeah,
Oh, okay.
graphing calculator, that is called Desmos.
Oh,
O-
no, I don't have it.
okay, okay, I'm
But I can get one online. Yeah, I know there is someone. Okay,
yeah,
so you
there's a
put
okay, I'm
to make that. I'm
I'm
sorry.
giving you the tools, giving you the material link here. Okay,
Yeah,
I
I
have,
know there is one. Yeah,
okay,
there
okay,
are a lot. My phone is looking.
okay.
So you put you put the function, and it draws automatically
Yeah, it
the
draws
line.
automatically the graph.
Ah, okay, okay. I have never used this calculator. Okay, I try it later.
Okay, I will. I have already shared on notes materials section.
Okay, thank you.
We can easily use this one to draw a function. You just
Okay.
put the equation or function here over there, then it will give you the graph directly. So for this you don't need to find out the values of x and y's, then put it on the graph paper, then join the line. Nowadays we don't need it.
Mm, good. Okay.
And also if you need any point on that graph, you can easily just click on the graph, then it will show you the point, coordinates of the point.
Um, yeah, right. I see that. Wow. Yeah. -5. Okay. Yeah.
Okay, okay. Now if we move on, that is now, so here we are given another equation, that is y equals to negative x cube plus 3x. That is the equation. So the equation is, here the equation is y equals to negative x cube plus 3x. So we are given a graph over there. We are asked to find whether the graph is uh, okay or not. Is the
So
graph
we have.
is correct one?
So we in this case we should replace y by -2 and the x cube by -1 and c.
So if we put
What is
x equals to 0, then we will have y equals to also 0.
right?
Right, okay. So for x equals to 1, then we have y equals to
Two.
2.
Uh, yeah,
2, okay.
yeah.
And
Plus
then for x equals to negative 1, then we have here y equals to negative
1
2. Negative 2.
-2.
Yeah.
Oh,
Now
oh.
if we go to geodesmos, then we can see y equals to negative x cube then plus 3x. So what type of function is that? Yeah.
Yeah, it's not correct.
uh, from the function we can also from the graph of the function we can easily find the domain and range also, and using the graph we can identify whether the given graph is a function or not. We can also learn that. I will
So
discuss about it.
how can we say so? Is it a function? This one?
This one is a function, right?
Yes. And
But
also the first one, no,
first one
because
was also a
the
function, since
values
that
are not.
that was a straight line, so it was a function.
Uh,
Okay, now
and when can we say it's not a function? The when we are using just the graph.
okay, basically the condition to check a graph whether it is a function or not, that is called the vertical line test. Vertical line test, that means if we move a vertical line along with y-axis, that is vertically, okay, and if the line intersect the graph more than one point, then we can say the given graph is not a function.
Like this one, because this one is not a function because the graph is there is because here we can find the y is 2 and also y. Where?
So this one is just like this. Okay, so if we just move
Yeah.
a vertical line, so if we move a vertical line here, so what we see if we move a vertical line, so that means the line intersect the graph in one point only. Okay, one point only. One point here is also one point, so we can say this one is a function.
So the y should be unique.
Y should be
But
unique, right?
x.
For x's, y should be
Um,
unique. But what will happen for this? Uh, if you are given a graph just like this, what will happen here? If we draw just move a vertical line along with just on the graph, so what we see here,
y intersect with two line first.
the
Yeah,
line
two
intersects the
times.
graph with 2 points, right?
Yes.
First one is one, the second
Right.
one is over there. So that means for each x, so for one x we have two y's, and the
So it's
condition
not a
was
function.
for a function we can't have two output for one input, right?
Right. Yes.
So this one is not a function.
Gotcha. I understand now. Yeah.
That is called vertical line test. And here is the definition of the function now. A function is a correspondence between two sets of elements such that to each element in the first set, there corresponds one and only one element in the second set. That means now if we consider a set, two sets, if we consider two sets, 1 2 3, so here 3 4 5, so we have to just get, if you consider first one as A and second one as B, so we must have to get one element in the for one element in the first set, we must have to get one element in the second set. Okay, so this one is a function. Now
Yes.
can you check whether this one will be a function or not? 1 2 1 2 3, this one will be a function or not? Second one.
Uh, the second one is a function, but the first one no, because we have two outputs, and we can't have two outputs for.
So will
For
it
a
be a
function.
function? Will it be a function?
The function is the 2 3. The first one is not a function.
No,
One one or
okay.
one
I'm talking
two.
about the whole scenario here.
Uh-huh.
So this one is not a function, right?
But the set of 2 and 3 is a function.
Okay. No, here there is only, we have to consider the whole set. Okay, we have to
Okay.
consider whole set. That is first one and second one. So
Okay.
here is the relation, that is called the relation R, such that A to B. But if it is a function, then we just write it as f A to B. So that is only the mapping. This one also called the mapping. So every mapping is not a function, right?
Okay.
Now, can you check another one? Uh, that is 1 2 3, and another set that is 2 3. Okay, okay. Will it be a function?
Yes, it is a function.
What are conditions saying?
But what about
What about 3?
the? Yeah. What about 3? There is no.
Is there any
So it's
output
not a
for
function
3?
because
Is there any output for 3?
no, nothing.
So can we call it a function?
No, it's not a
No,
function.
no, right. This one is not a function also. But what about this? that is 1.
No, it's not a function.
It's not a function.
It's not a function. No.
No, this is a function. Okay, this one is a function.
But you,
Okay, let me
yeah, yeah, yeah,
explain.
yeah. Because one output. Okay, okay.
One output. For
But
one, we
what?
have.
I'm
But
sorry.
what about 2?
Yeah. What about number two?
So here, basically, uh, since we have said that we can compare a function with a machine, right? So in different factories, there are some outputs which just like as oasis. But- So from here, basically, uh, i- uh, we have 2 here. Okay, that will not matter. Or that these 2 will not hamper the condition. This 2 is not hampering the condition, since we are asked to, for each element in first set, right? For each element in first set, there corresponds one and only element in the second set. Okay,
Yes.
so what we learned from here, there can be an extra element, there can be extra elements on sets B, but it can't happen for set A.
Okay.
Okay,
Yes.
and also uh, in set B, one elements can be associated with 2 or more than one elements with the set A.
Yes.
But for being a function, uh, elements which are on A can't be associated with more than one elements in B. Okay,
Yes.
so I think now it's clear to you.
Yeah, yeah, yeah. It's
Okay,
clear now.
okay, okay. Now we can easily decide whether given sets, the relation between or mapping between 2 sets or function or not.
Right. Yes.
Okay, then we can move forward. Uh, Here, we are basically now gradually moving to the application of the function, that is application in real life. Okay, here function specified by the equation. We see a rectangle, right? Okay, and the length is x, and the breadth or width is x minus 1. So what will be the area of this rectangle?
Uh, it's y equal to x x minus one.
Yeah, y equals to x times x minus 1. Okay, and the condition is x must be greater or equal 1, since the
Yes.
length can't be negative, right?
Right. Yeah.
Even if it is 0, the value of x is, sorry, 1, so we will have the width is 0. So for a rectangle, width can't be 0 also. That's why the condition for x is it must be greater or equal 1. Now from here, for each input, so we can now call this one as a function. also. If we try to verify it, then for each output input of x, then we have output area y. We are calling y as the area. So for x equals to 5, we have y equals to 20. So for x equals to 1, we have y equals to 0. Okay. And here is the definition for a function in terms of equation. That means for if we get exactly one output value for each input, the same uh, condition we have already discussed.
Right.
Okay. And we also discussed about this theorem, that is vertical line test for a function. Okay.
Yes.
Now sketching the graph of each equation. If you are asked to sketch, then you don't need to be accurate. You just if you just find out the shape of the graph, then it is okay. So we have already discussed about this also. If you are given an equation, that is y equals to 9 minus x square, so for every x we have to find out y. Then we have to put these points in a graph paper. And join the lines, then you will get the graph. Here is the graph of first one.
So we have just to substitute the x by the number in the table. That's it.
Yeah. Then we get the table here. For x equals to -4, we have y equals to -7. Then for -3, we have y equals to 1. Then for x equals to -2, we have y equals to 5, just like this. And then
Yes.
put the points here, -4, then -7. These are the points, okay? And then -3, and y is 0. And then for -2, y is 5. So just put these points on the graph paper and then try just join it. For x equals to 0, we have here 8, just like this. This one is 0, 8, sorry, 0, 9. And then for 1, we have here 8, and then -8. For -1, we have 8 here. -1, 8. The graph of the function is just like this. You can nowadays we don't need to actually draw a graph paper. You just put the data in the Desmos or GeoGebra, something like this type of apps. Or you can also use calculator.
Yeah.
Do you have the access? Can you
To the
use
calculator?
calculator GDC?
No, I don't have it right now.
Okay.
Because I don't have my phone.
Okay. So you can also put the equation over there, then you will get the graph.
Yeah. I try later for sure because I have to
Okay.
how it works.
Here is the next one. Okay. Now I have also discussed about this table. We are given here 3 tables. So can you tell me first one? Here we are given number and then cube. It is numbers are associated with cube. So first table, data as of first table, is it a function or not?
Yes,
Yes.
because we
Okay.
have for each input one output.
So then, if it is a function, then we can say the elements of first set called domain. Okay, and the elements of second set called range. Is it clear?
Yes,
Okay.
clear.
And then what about the second one? Is it a function?
Yes, it is a
Yes.
function.
Okay, this one is also a function, this one also a function. So now what about table 3?
No, it's not a function.
It's not a function. Good. So you can easily identify from a table also, right?
Yes.
Okay. Then if we move on to the next, that is, we are given some functions and we have to identify some values. Okay, calculate first one. We are given here f of x equals to 12 over x minus 2. Then find f of 6. So how can we find it?
Just we have to substitute x by 6.
Okay.
So f the 6 equal to 12 over 6 minus 2.
Okay.
It's 12 over 4.
Okay.
It's, yeah.
So the result is
3.
okay, that is 3. And then what about g of negative 2?
So it is,
And we are given here g of x, that is equals to 1 minus x square.
it's 1 minus 4. It's minus 3.
Okay, 8. So the result is 3, minus 3,
So it is
minus 3.
also.
Okay. So I think now you can calculate the
Yeah.
rest. Okay, okay. Here is uh, example 5, that is finding domains. Okay, now I need to discuss about this. How can we find the domain of a function? That is, here we are given f of x. F of x equals to 12 x minus 2. Okay, since this is a rational function, this type of function is called rational function. We have denominator and we have numerator. So uh, if we try to recall the definition of the function, there are we are said that for each element, for each input, we must have only one and only output, right?
One.
One and only. If we don't get the output for any input, then we can't say uh, the value is under the domain, right?
Okay.
Okay, so now if we look at the function here, uh, here we are given, we have, if we get this value as 0, so something under 0, that means 12 by 0. So what will happen here? Do we get
No,
any?
it's not. No, we can't
We
because we
can't.
can't have zero in.
Okay, so we can't have 0 under something. That means this is called
Right.
undefined.
Undefined. Yeah.
Undefined form. Okay, undefined form. So if we get x minus 2 equals to 0, that means x equals to 2. So if we get x equals to 2, then the value f of x is undefined, right?
Right.
That means, what does it mean? That means for x equals to 2, we don't get any output.
Okay.
We don't get any output. That means 2 can't be considered as domain. So domain, we can say x minus 2 for domain, for domain x minus 2 can't be equals to 0, so x is not equals to 2. That means d of f equals to, we can consider all real numbers except 2.
Yeah. Got you.
That is the notation.
Mm-hmm. Yeah.
Okay, we can also
Yes.
rewrite this in different form. That is, uh, do you have any idea about closed interval, open interval?
Yes. Yeah. I remember something. Yes.
Okay,
Something.
uh, it
It's when it's closed, it's included. Number is included. When it's open, it's not included.
right. Here, if we are given here x, the value of x is in between 2 and 5. So if we draw a number line, if we draw a number line, that is 2 and 5, that means the value of 2 and 5 included, right?
Yes.
Okay, so we can write this as 2 5. Okay, that is called
Mm-hmm.
closed interval.
Yes.
But if you are given here the value of x is greater than 2 and less than 5, then it means here we will not consider 2 as the value of x. We can't consider it.
So.
So
So. Two.
just
Two and
we
five.
have to we can fill up the circle. Okay, so these are the values of x. Then we can write this as 2 comma 5. That is called open interval.
Yeah.
But if we are given just like this, then what will happen here?
first one is not is included. The second five is not included.
So we can write 2 5. So we can put here third one, and we can put here first one, right?
Right.
So what does it mean? If we use third bracket, that means the value is included. If we first bracket, then the value is excluded. So the name of the bracket is closed open interval. Closed. First one is closed and second one is open, so it called closed open interval. Okay.
Yeah.
But
Yes.
if we have here 2, then we can write 2 5. So 5 is closed, 2 is open, that is called open closed interval.
Yes.
Open closed interval. And for in case of R, in case of R, set of all real numbers. So if we draw a number line, then we see here positive infinity and it will be up to negative infinity. So all the numbers on the number line is under R, right? So we can also rewrite R as negative infinity to positive infinity. And since infinity is not a fixed number, so we will always use first bracket with infinity.
Oh, yeah. No, that's why. Okay.
Okay. Now we just got the set of domain, that is all real numbers except 2, right?
Yes.
Okay. Now how can we rewrite this using brackets?
So we can put negative infinity uh,
So
2.
if we consider this one as 2, so it will be negative infinity to up to 2, then after 2 to positive infinity, right?
Yeah.
Okay.
Union. We have to put union.
Right.
Yes.
So we have here two sets. First one is negative infinity to 2. 2 is included or excluded?
Excluded.
Excluded. So we have to use which one?
Uh, Parenthesis.
First bracket, right? And for infinity we always use first bracket. Okay. And then what about second one? Then
It's
2 to
2
infinity.
plus
2 to infinity. And 2 is included or excluded?
no, it's not included.
Not included, right? So we have to use first one, and we have to always use first bracket with infinity. So that is the union. So
Yeah.
this one also can be written as like this.
Okay.
both of
Thank you.
both of them are same. Okay.
Yeah.
Okay.
You know,